Good afternoon, everyone. My name is Richie Carlson. I'm the Director of Energy here at Pollution Pro. Uh, I am today talking to you from Toronto, which we acknowledge the land we are talking to you today is on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis people from across Turtle Island. We also acknowledge that Toronto, where I am today anyways, is covered by Treaty 13 with the Mississaugas of the Credit. For those of you who don't know about Pollution Probe is Canada's longest standing environmental organization. We pursue environmental gains by trying to work with everybody, governments, industry, and the public, with a steadfast commitment to clean air, clean water, and a healthy planet. On my team today, Ruth Kira, who led the research, is joining us. So she may be coming in later to answer some of the questions. And I'd also want to introduce Jake Brooks. Jake, do you want to quickly say hello? I think you can unmute yourself, Jake.
Sorry, I was muted. I was a help pollution probe. I'm an independent consultant from Toronto, and I help pollution probe on this project.
Great, thanks for coming here. And of course, I'd like to give a big thank you to the Atmospheric Fund, TAF, who, without their generous support of this project and other projects like this, we literally wouldn't be here. And it's great to have people who are providing or helping organizations like us try to provide some new thinking into the Ontario energy system. Today, we're going to be trying to keep it quite short and quite brief. So the first part I'm going to be providing an overview of the findings from our 2024 report, Achieving Reliability in the Future Ontario Power System and Action Plan. This will provide a very high level summary of what we've talked about. We will then have we're going to try to have a moderated discussion, because we really don't want this to end. We're interested in ideas and suggestions and what people think about what can Ontario do to increase the use of existing and new non-emitting resources to economically provide reliability. We're going to need to use all resources. We're hoping we really need to build off this and figure out what are the next steps as we go through. Just a quick overview about the Net Zero Reliability Initiative. So our goal was really to identify and develop cost-effective opportunities for non-emitting and net zero resources to support the economic decarbonization of the Ontario power system. And we also taking advantage of all the services that these new technologies can provide. And we did this through a mixed methodology approach. So first, we had a preliminary technical analysis by Power Advisory, which are a consultancy. And we also conducted a jurisdiction scan of different ways that other jurisdictions across the world are looking into how new net zero and non-emitting resources can enhance reliability. This all informed a stakeholder session, which was held in late April 2024. And that then led to our final report. We were very much helped through the use of a advisory council, and the names are there for the people who are involved. As you can see, they provided some fabulous feedback and really helped us with our thinking. And we would not be where we are now without the help of the advisory council and, of course, all the participants at the stakeholder workshop last year as well. So we really appreciate everyone's contribution to our thinking and to help us really try to progress this project on. Before we go any further, I want to briefly go over what we mean by reliability. Reliability is, of course, ensuring that electrical services is available to consumers and that power quality is protected. The province is working on ensuring energy and capacity needs with their long-term procurements. But reliability is more than just making sure we have enough megawatt hours and enough megawatts to meet demand at all times. So that is, of course, quite important. The electricity system does need to be balanced on a second-by-second basis. And so in addition to capacity and energy, there are other reliability services that need to be accounted for. These reliability services differ between on the bulk system as well as on the distribution system. On the bulk system, which is managed by the IESO in Ontario, the These are provided generally through contracts, or sometimes in many cases, like inertial response, is provided just through the generator itself and the way the generator actually works with their spinning mass being able to provide inertial response. Uh, we should know, I just want to note at this moment that we are currently getting these reliability services. And this is not a criticism about what is happening now. This is really us trying to prepare for the future and to try to take advantage of the investments that is happening. So at the moment, we are getting the reliability services are happening, and Ontario does have a reliable electricity system, but we really want to make sure that we're preparing for the future and understanding what does need to change in the future as Ontario's energy system changes. Another important part, just to kind of give a bit more information on the aspects of reliability, there's different types of reliability, and there's a big temporal aspect as to whether or not it's instant or less than a second, all the way up to hours and days. As I mentioned before, the duration energy assurance is really being provided at the provincial level through those long-term procurements that the government is undergoing. And we're focusing primarily on the reliability requirements that are sooner, looking at inertia and frequency response, regulation services, which is being able to meet demand if it changes, as well as operating reserve, ramping, and flexibility. So really the kind of the short-term reliability services, the ones that happen that have to be addressed very quickly. And of course, becomes the question as to if it's not broke, why fix it? And that is always an important question, whether or not this is a problem that we do need to solve. And we would argue that we do need to solve this because while reliability services have worked in the past and what we were doing has worked in the past, the electricity system is changing, and we need to change reliability services to make sure that we can meet future reliability needs, as well as take advantage of all the services that the new technology can provide. And we don't want to be leaving money on the table or services on the table, as that will just lead up to increased costs for consumers. So the first way the electricity system is changing is the electricity demand is changing. It should come as no surprise to you. For many of you on this call, electricity demand is projected to rise by a lot. Even in conservative modeling, demand is projected to double over the next couple of decades. At the same time, the demand profile is changing. New industries such as data centers and the like do not have the daily peaks that previous industries such as factories or industry has seen. Plus, DERs and the rise of DERs such as solar and storage are leading to changes in demand and the way consumers deal with their energy. And this leads to uncertainty over how the future will look, what's going to be the future demand, and how are we going to meet these reliability needs through the different, with the unpredictability and the fast changing of demand, given that the new technologies are going to be changing the demand profile. And of course, it's not just the demand is changing, the electricity supply is changing. And what is key is we're going from a shift from large centralized fossil fuel generators, or in Ontario's case, maybe nuclear generators, to non-emitting facilities. This is probably more in Ontario, will be more of an additive approach, as we're going to be continuing with a lot of some of the existing non-emitting resources, but we're going to be adding a lot more non-emitting facilities of various types. And this is the worldwide pattern. This is not just going to be happening here as cost decline. I think it is now clear that on an electron basis, solar is probably one of the lowest cost forms of energy, but of course, and we're seeing more wind and solar, and we need to figure out how do we fit all these new types of resources in, and how do we make sure that we continue to have a reliable system as these new technologies come in. There's also an increasing amount of inverter-based resources. Before, with hydropower and natural gas and nuclear and other generation, there were primarily spinning resources. The turbines were spin, and that provides a lot of inertia, and they're synchronized to the grid. In the future, we're going to be getting a lot of inverter-based resources such as solar, wind, and battery storage, and that is going to change the nature of the grid. And many of these inverter-based resources, while in the past have not been used to provide reliability, can be used to provide reliability in in certain circumstances. And we're seeing a rise of grid forming inverters and the like under development in many jurisdictions. Australia is one of the leading jurisdictions on this, but we're seeing other ones looking into the role of inverter-based resources and how they can contribute to grid stability and not lead to problems as they expand. New resources means they need to provide new reliability services. We don't want to leave money on the table. So if we don't take advantage of the resource of the services that these new resources can provide, then we're just wasting the value we can get from them. And by taking advantage of the value we can take, that we can reduce costs for consumers, we can reduce system costs, and make sure that we're getting the best bang for a buck at the time, for all the investment that's going to be happening in our energy system. It's also important to note that a lot of these new resources are going to be located sometimes on the distribution system. In most cases, a lot of times, not just on the distribution system, but we'll be seeing a lot more. And there's also an opportunity for these new resources to provide additional benefits, such as non-wire solutions, and to help reduce costs in that way and help provide services in the distribution grid through providing non-wire services and being able to reduce the need for infrastructure investments, or defer the need for large infrastructure investments through meeting system needs. And to give you a sense of some of the reliability characteristics of non-emitting technologies, this table, which is from our report, provides you an overview. While one technology may not be able to provide all services, unlike some other existing technologies such as hydropower, which can, depending on the water requirements and the water flow requirements, can provide a lot of the services. A lot of the new technology are unable to provide all the services, but they're all able to provide something. And this is also not to say that this has never been recognized. And we've seen examples in the past of where battery storage has been procured for meeting reliability services already in Ontario. It's really just a matter of how do we make sure we are prepared for the coming technology and a lot more of it being developed onto the grid. So when we also look at in addition to the changing of the demand and of the supply, we're also seeing that there's going to be more focus on the role of the distribution company. More of the supply will be distributed connected. We are seeing a huge rise in DERs. That's probably going to be expected, and all the modeling shows that distribution companies and the distribution system will be playing a large role in the future energy system. So we have to consider what is the role of distribution companies. Consumers are moving and distribution needs to come with them. The consumers are moving from, as we were saying before, from static and predictable loads into dynamic participants. They are able to both take and receive. They're able to both be a load and a supply at the same time. We have to figure out what is the best way of ensuring that consumers becoming more dynamic participants can provide more value to the system, and they're able to benefit, make sure that everyone can benefit from their operations. They'll need to manage things differently and take advantage of the new technologies, and being able to respond quickly and flexibly will be important. We need to look at the need for flexibility services at the distribution system. And flexibility in this context means that a resource can rapidly increase or decrease demand as required by the grid to contribute to grid stability. Such flexibility can be provided by small-scale generators, such as a solar system or battery system, or solar and battery repair, or it could also be provided by demand response. And these flexibility services could support frequency, voltage, and other reliability services. In some jurisdictions, particularly in Europe, already procure frequency resources from local flexible resources. The UK has introduced a local flexibility market through which small-scale distributed assets can participate in local markets. And in 2024, system operators in the UK contracted almost 4 gigawatts of flexible resources, 75% of which were from non-emitting resources, which is 700 megawatts more in 2024 than what the year previously. And it was estimated that in 2023, 2024, flexibility in the UK provided 91 million pounds in benefits to consumers through reduced need for distribution network infrastructure investments and an additional 109 million pounds in facilitating the greater use of DERs without requiring network reinforcement. So they're able to bring on more DER systems onto the grid without having to invest more into the grid in order to make sure they can be accommodated. So they're able to ensure that the benefits that these DERs can provide did not come with the additional costs that may have happened. And in the European Union as a whole, modeling has indicated that there could be a cost reduction of around 70 billion euros a year by 2030 due to flexibility. Plus, of course, there are also the indirect benefits of reducing emissions and giving people control over their supply and helping people understand what is the role they're going to play in the energy system and making sure that they can contribute to decarbonization and feel like they're playing a role. But managing this will require distributors to change the way they operate. And there's been a long-term debate over distribution system operators or what is the future of local distribution companies in Ontario and whether or not there's a need for what is known as distribution system operators, where local distribution companies like our LDCs in Ontario actually operate their own local system, or if the ISO, or one other suggestions include the ISO could expand its operations further into the distribution system as well, or some combination of those proposals. But there's been long debate, probably going over more than a decade from my experience. I've been reading papers about this for a decade. And so far, there's been no decision. There's just people debating whether or not what would be the greatest benefit to Ontario's energy system. And just to highlight what we are talking about, there is, of course, this kind of shows you how the future energy system is evolving. And you can see that on the consumer side, we're going to be seeing a lot more distributed energy feeding into the distribution system, where there's going to be a lot more in front of the meter connections contributing to the system, and then going into the transmission generation. So it's really more of a complication, and the role that customers are going to be playing a much larger role, and it's become much more important. And they can help meet system needs and reduce the need for infrastructure through non-wire solutions. But we need to make sure that the right regulatory environment is made available so they can actually contribute to the system as a whole, and not just and provide reliability services and help everyone out. Of course, we don't need to reinvent the wheel. Other jurisdictions are also working at the same issue, and Australia is one of the lead jurisdictions looking at this. And they have a new rule that allows pre-investment distribution analysis for evaluating non-network options or non-wire solutions. They have frequency performance payments, whether market participants can be paid for their positive and negative frequency performance, in order to contribute to ensuring frequency stabilization. And there's even a company, Reposit Powers, that offers 7 years of free electricity if customers purchase the solar storage and controller package from them. And this allows them to control the system and basically act as a virtual power plant in what they refer to as ancillary markets. And they can that allows the company to make up for customers having free electricity. In the US and some jurisdictions, we're also seeing quite a big change. In California, energy storage is being used to improve grid reliability, and it's full use by the ISO. In Hawaii, Sunrun is operating a virtual power plant that dispatches power at peak demand, and that helps reduce customer bills. I mentioned before, we're already in the UK, all flexibility projects, flexibility markets, and they have products including peak reduction, scheduled utilization, operator utilization, and scheduled and variable availability, and depending on all the different resources submit their bids and submit their operations, they get paid in different ways under different processes, whether what kind of flexibility they can provide. And Sweden, local resources such as EV chargers, backup generation units, and home energy management systems can also participate in frequency restoration events as well. So you see, there's a lot happening, and we're in other jurisdictions that we can borrow from. Just to go back, from based on the research we had and from the workshop, and then going through the workshop and the results from the workshop with the advisory council and other stakeholders, we created a detailed action plan, which you can see in the final report. And I'll just provide just a quick overview of it. If you want all the details, of course, you can download it from our website. The first one is Ontario should competitively procure bulk level reliability service from all types of resources, including non-emitting resources. And this would ensure that Ontario should explicitly procure reliability services in ISO procurements. And for example, at the moment, a lot of the reliability services were contracted are not part of the long-term procurements. LT1 has been done, and LT2 that will be happening later this year. And in some cases, the reliability services are just bundled with the contract that the generator has with the ISO. So we are saying that there should probably be explicitly procured in order to make sure a lot more visibility in the market, so people understand and the market can understand what kind of reliability services are needed in Ontario, and what kind of compensation is available for them. In the longer term, there's the possibility of reliability services auction, which would be a technology agnostic market probably with a preference for non-emitting resources in order to provide reliability services. And these reliability services auctions at the bulk level could be coordinated with a distribution focus RSA or flexibility market as well, to make sure that both bulk level and distribution level reliability are maintained. The second one would be in a lot of this and how this is going to be rolled out. We really need some clarity on the future role of LDCs in Ontario regarding system operation and reliability. And we really need to set a vision and design for what is going to be the new regulatory regime for local electricity markets, and to clarify the role of the LDCs. And the first report I have read I remember on the future of the LDC was written about a decade ago. And apart from a few pilots looking into how different aspects of that could be used in Ontario, and more reports, including some that I've worked on. So I am contributing to this wealth of reports on the future of the LDCs. There's yet to be any clarity as to what will actually be done, what, if anything, will actually be done. And time is coming up. It's already 2025, and 2050 is only 25 years away. And if investments are going to be made and we're going to be setting up some of these new markets, there really needs to be clarity on what will the future of the LDC look like, how can markets work for that, and how could we probably set these up. And for that, we really need some clarity on how we see these different market players act in the future. We also call for enable development of local flexibility markets for reliability. And these, as we mentioned before, could be coordinated with the RSA auctions at the bulk level. And there could be explicit local flexibility markets, such as local reliability and local voltage stability support auctions. And the preference could be made with projects that could provide multiple benefits, such as maybe a project that is also a non-wire solution and could also provide flexibility services. And back to what we were talking about before, the LDCs will really need some clarity on their role. And more data availability will also be required by all operators, and make that publicly available. There's some work being done on that already, but we're going to be needing, if we're going to be having flexibility markets and looking at non-wire solutions and hoping to get investment made, we're going to be needing a lot more information on what is the state of the grid, what is the state of reliability, and how different projects could contribute to improving and provide benefits to customers. And lastly, we need improved coordination between transmission and distribution. And this could coordinate on we need to coordinate on future methods for procurement and operations and improve on data sharing between the bulk system and the distribution system. And that would feed into what kind of non-wire solutions are available and what kind of projects would be needed to support reliability. And all this to say is, while there will be need for greater coordination between the ISO and the LDCs, there is already coordination going on. There is, so we're not saying there's nothing happening, but the ISO and the LDCs do coordinate, but we need to make sure that that happens in would happen more as more clarity on who is going to be doing what and how that's all going to contribute to stability of the system. And that will probably lead into who is responsible for what and more clarity on roles and responsibilities in the future. So that is a very high level overview. You can read on our website, which is at the bottom of this page, you can read the final report. We also have the jurisdictional summary and the technical analysis online, so feel free to read that as well. We do want to continue looking at the next steps, as we're mentioning that we don't want this initiative to end. We need to move to implementation and to promote early movers. But before we move on to discuss the next step, are there any questions about what I have presented here? Are there any questions or comments that people want? I believe if you raise your hand, I will see, or if you want to just if you just want to write a question in the chat, we can see that if there anyone has any comments, questions, concerns, please do let us know. Okay. Everyone understands perfectly. Well, I'm glad to see that. Now I want to kind of move on to what are the next steps. I'm going to hand over to Jake, who's going to be leading some of the discussions, and we really want to hear from you and find out how you think. What are now that we've kind of set the high level overview of where we kind of need to go? How can we start making steps in the right direction in order to start moving this forward so that we can have a cleaner and more reliable system in the future? Jake?
Okay, thank you, Richard. As mentioned earlier, I'm an energy consultant based in Toronto, and I help Pollution Probe both develop and carry out this low carbon reliability project. And although most of you who know me would better know me more from my previous role as executive director at APRO, where I worked for a number of years. But at this point in the session, what we're trying to do is hear from you. I'm going to start by putting a few high-level questions on the table, really only as food for thought, and open the floor for what we hope will be a free-flowing discussion. I want your ideas, your thoughts, and suggestions on how technology for low-carbon reliability can be most effectively developed and advanced through the many systems that affect the power grid. So at a high level, the general question on our mind, what can Ontario do to increase the use of existing and new non-emitting resources, particularly DERs, to economically provide reliability? Are there certain priorities you feel need to be highlighted? Are there any barriers that you feel need to be addressed first? This is the kind of thought we'd like to hear. Maybe I'll just pause and ask if there's any reactions to that general opening. Some examples of the kinds of things we've heard might be interesting is to look more closely at underutilized resources like ICI BTM. I guess probably most of you probably know ICI BTM is Industrial Conservation Initiative behind the meter resources. Can we provide a revenue pathway for these resources? There's a lot of underutilized resources in this category. Are there other types of underutilized resources that could provide reliability in a economic and attractive way? Third kind of high level question, you might just call this an area for consideration. And Richard alluded to this, of course, managing the uncertainty over the scope of LDC activities. Don't really know how broad the LDC can, how broadly the LDCs will be able to operate in terms of providing reliability upstream. And of course, related to that is how can LDCs move forward on reliability services in the absence of a clear decision on the direction of the boundaries of their roles? That's some high level questions. Any reactions or suggestions to those high level questions at this point? Not.
I should note, Jake, I'll stop the recording now so that
Sure.